Now proceeding with the chapter chemical kinetics. Today we have to solve some numericals based on the rate of reaction. Say for example we have highway, this gives 6b plus 9c. This is a general reaction that we have taken. Now, if a rate of appearance of C is equal to 15 mole per liter per second. If the rate of appearance of C is equal to 15 mole per liter per second, then calculate a rate of appearance of B and a rate of appearance, rate of disappearance of A. This is the question. Now, the solution is like this. We have a general expression for rate of reaction as a rate of reaction is equal to minus 1 by 5 D concentration A by dt, which is equal to 1 by 6 D concentration D by dt, which is further equal to 1 by 9 D concentration C by dt. This is general expression for rate of reaction that we have already done earlier. Now, since the rate of formation or rate of appearance of C is given, that means we have D concentration C by dt. This is equal to 15 mole per liter per second. This is given. Now, first we have to calculate the rate of appearance of B. Then we consider this two part. I mean relation in B and relation in C. B with C. So we have 1 by 6 D B by dt is equal to 1 by 9 D concentration C by dt. Now we have to find out D concentration D by dt. This is appearance of B, rate of appearance of B. So this will be 1 by 9 into 6 into, and we have dc by dt as 15 mole per liter per second. So here is 3 3 are 9 and 3 2 are 6, 3 5 are 16. This is equal to 10 mole per liter per second. So this is a rate of appearance of B as 10 mole per liter per second. Similarly, we can calculate for rate of disappearance of A. Now, rate of disappearance of A. Now, a rate of disappearance of A. For this, we consider any of the relation, either relation between A and B or A and C, whatsoever. So we consider minus 1 by 5 B concentration A by dt is equal to B 1 by 9 D concentration C by dt. Now we have to find out minus D concentration A by dt, because this gives rate of disappearance. This is equal to I by 9 into 15, and this will be 3 3 by 9, 3 5 by 15, 3 25 by 3 mole per liter. So in this way, we can find out the rate of appearance and the rate of disappearance. So there are a lot of questions. I think nearly 15 to 20 questions are there in the book, and you can go for that, no problem at all. However, if you are facing any problem, you can ask me in the doubt session, in between 3 to 5 p.m. every day except Sunday. Okay. Now we proceed for the next topic, very important topic in this unit, that is order of reaction and molecularity of reaction. Reaction and molecularity of reaction. Order of a reaction and molecularity of a reaction. Now, first we come on to order of reaction. For this, we again remind our work on rate law, and we have already discussed rate law comes through law of mass action. So again we consider the reaction like this. We have the general reaction. We have already taken this reaction earlier also. So again we recall this reaction. For this, rate law is written, or rate equation is written as rate is equal to K into concentration of A to the power M and B to the power N. This we have already written. In place of A, we write M. In place of B, we write a small m. These M and M are the actual number of moles of A and B respectively to take part in the chemical reaction experimentally. This is very important. So if you write A and B, power as A and power as B, this will be given theoretically. But here we have to write rate law. That's why we always do it experimentally. So this is the rate law for this equation. So here order of reaction, order of reaction is equal to M plus N. This is order of reaction. So whenever order of reaction is to be defined, so this is sum of powers of concentration of reactants expressed in the rate law, which is given experimentally. This is the general definition of order of reaction. Okay. Now we have various equations on different order of reaction. So here, say for example, we have suppose here is NO okay, let me write. I am just giving you an example. Here is NO2 plus F2 and here is 2NO2F. This is a reaction, and for this reaction the rate law is given as K NO2 concentration F. This is given. What does it mean? If you have to know the order of reaction for this reaction, then we have to consider this rate law because this is obtained from experimental part of this reaction unit. So here the order of reaction, here the order of a reaction is equal to 1 plus 1. It has got power 1, this has got also power 1. So 1 plus 1, this is equal to 2. So this is second order reaction. But if the reaction is only seen theoretically, then its power will be 2 plus 1 is equal to 3. So in confusion, lot of students reply the order of reaction as 3, which is absolutely wrong because rate law is given and rate law comes through experiment. So the experimental part of the rate equation gives us exactly about the idea of order of reaction. So here order of reaction is 2 but not 3. So in this way we have many reactions: zero order reaction, first order reaction, second order reaction, third order reaction, fractional order reaction. So we have various types of reaction of different order. So you take one question. The question is, I am giving you a question on order of reaction. The common question is, write an example of A zero order reaction, B first order reaction, second order reaction, D third order reaction, E fractional order reaction. Fractional order reaction. So you give at least one example in each case, and this is for your homework. Now we move on to molecularity of reaction. Molecularity of reaction. Now, molecularity of reaction mainly deals with the number of simultaneous collision of the reactant particles. Simultaneous collision. You know, when we consider a reaction, say for example, we have suppose this is a reaction which is formation of water, everybody knows. We consider this reaction. Now, if this reaction is carried out in one step or with simultaneous collision as simultaneous collision, 2 plus 1 equal to 3. If simultaneous collision is 3, 2 moles of H2 and 1 mole of oxygen. If all the number of moles take part in the simultaneous collision, then here molecularity will be equal to 3. But we cannot expect, we cannot guess the number of moles which are given in the balanced chemical reaction. All will be taking part in the simultaneous collision. That's why it has been observed that simultaneous collision is not more than 3. This has been observed. So sometimes the reaction is taking place in more than one step. So here the nature of reaction is of two types. One is elementary reaction and second one is complex reaction. So whenever a reaction takes place in one step, that is elementary reaction. And when a reaction takes place in more than one steps, that is called complex reaction. So whenever we talk of molecularity, molecularity is meaningful for elementary reaction only. So in elementary reaction it has been observed that the simultaneous collision, number of simultaneous collision should not be more than 3. If it occurs, that means this is not the elementary reaction or simple reaction. This may be the complex reaction, and that complex reaction may contain more than one step. Then molecularity will be different or sometimes will be separately expressed for each step of the reaction for complex reaction. That's why in case of complex reaction, molecularity has no meaning at all, but it is meaningful for elementary reaction only.